Okay, so good morning, everyone. We're going to start 1.1, which is functions. 1.1 to 1.3, as I mentioned earlier, is practically just review. So I'm not going to lecture too much and in detail. Okay, so I'll just pick up several important topics to discuss, but all the other ones are review. So today is the first day we're going to do it, and I am going to share my window. All right. So if you have a question, Diana or Oscar, you could ask me. Yeah. All right.
Okay.
Okay. So I'm not going to be able to see this anymore, but I'm going to share my desktop. All right.
Okay.
Okay. So I'm going to close this, and I'm going to make this bigger. Hold on. Okay. Good. So 1.1 function. So feel free to take notes. Yeah.
Okay.
So we will talk about a relation and then a function. So a relation is a correspondence between two sets. So it doesn't have to be mathematical relation. It can be so the number, the capital cities, or the price of, but it does not have to be a mathematical relation. Yeah. So a relation. So this is a definition before. So a relation can be represented by an equation, graph, map, or table, or list of ordered pairs. You've seen this before, I'm very sure.
Yeah.
Venn diagram, etc. So this is an example of an equation, y equals to x squared plus 3. So this is a relation represented as an equation. And which one is the input? Which one is the output?
The input is y and the output
y depends on x. So in this case, x is the input and y is the output. Is that right?
Yes.
Okay. So number 2. I am going to graph a circle with radius 5. So maybe let me graph it first. Ooh. Okay, you could think of these as a nice round circle. Yeah.
Mm-hmm.
Does anybody know what equation represents this circle?
What equation?
Yeah. So this is a graph. I represent a relation as a graph. But I could also represent this graph as an equation. Does anybody know? Anybody remember equation of circles? What is it? Any idea?
I forgot it.
X squared plus y squared is equal to 25, right? X squared plus y squared is equal to r squared. Okay. Now the other one is as a table. So, let's see, what should we do here? Maybe your first name and your birth month. Okay, so who wants to share their birth month? Anyone volunteer? When are you born?
12.
I mean, what month?
September.
Wendy is November. And then I am born in May. Okay, anybody else? Yes.
December.
Jessica, April. Anybody else born in May, April, or November? Yeah. Oh, Edwin, November. Yeah. So Edwin, November. Okay. Now we usually write these and Jessica, and look at the Edwin. It's the same November, right? So what we're going to do, instead of writing another November, or actually we could do it, there are two options. You can write November again, or what is the other option? So I am going to write Edwin and then point it to November also. Yeah, or you could write November here. But from Edwin, I could point to November because I already wrote down November. Yeah. And I could also list these birth months, name and birth month, as an ordered pair. So how does your list look? So Wendy, November. Okay, what is it? Anne, May, Jessica, April, and Edwin, November. So these are ordered pairs. All right, so now we know a few types to define, to express relation. Have you seen this before? This is review for you, right? Okay, good. So if you're done, I'm going to go to the next page. Yeah. All right, and we will talk about functions. So if I look at my ordered pair here, which one is my input? What is my input? So domain is the set of all inputs. So what is my domain here? Yes, which is Wendy, Anne, Jessica, and Edwin. Right? That's the domain. Domain is the set of all inputs. How about the range? What are the outputs? The months, which are, you're right, November, May, and April. Now, since I already wrote November, I don't have to write it twice, even though it was paired 2 times for Wendy and for Edwin. Yeah? So we're just going to list November 1. So what is the definition of domain again? The set of all inputs. And range is the set of all outputs. Yeah? All right. Super, so good? So I'm going to go to the next page and talk about function. But we will have fun a little bit before we define function. Yeah? So B. Are you guys done? Okay. So B. So so a function is, and then I'm going to leave it blank. Okay. Now I have a few tables that I want you to guess what rule it is. So there is the input and there is out. So this is called in and out table. 2, 4, 5, 10, -3, -6, -4, -8. So my question is, can you write a rule to get the out? What is the rule? What is it? What is it? X equals to Y? No, you have to write it in terms of in and out. But you get the right idea. It's just that I'd like you to express it in terms of in and out. So how are we going to do it? Where is the in and out? We're not using X and Y yet. This is what I mean, yeah? You're right. What is it? Out. Yes. So multiply in by 2 to get out. To get out? Okay. So if you put x here, then here the out is 2x. You're right. So I'm going to ask you to guess a few more rules, okay? Is this fun? Oh, okay. So let's see. What about this? In and out. So I have 5 to -3, -4, so 14, 5, -10, -13. So what is the rule for this one? Any idea? And then let's do a few more so you can think. Yeah. So what about this? In and out. So 4, 13, 2, 1, 7, 46, -1, -2. And the last one, in and out. 2, 13, 1, 6, 5, 3, 4, 2, 23. Yes, what's your name? Eileen? Eileen? Yes. What is it, Eileen, for number 2? Okay, so let's try it. So Eileen said that for number 2, the rule is multiply in by 3 and then subtract 1. Is it true? Okay, so 2 times 3 minus 1, is it 5? Yes. -3 times 3 minus 1 is -10. So is it true? Yes. So multiply in by 3 and then subtract 1. So if I have x here, how do I write my out? Anywhere, like Alex here, we have a C. So 3x minus 1? Alright. And you can write down the words. Yeah. Okay. Now, what about the other in and out table? Yes, this is? What is it? Square it, and then? Okay. Or number 2 or number 3? Number 3. So square the in by 2, and then subtract 3. Is that true? Now let's check. So if I square 4, it is 16 minus 3, 13. So that's correct. So square 2, 4 minus 3 is 1. So square 7, 49 minus 3 is 46. And square this, what is -1 squared? 1 minus 3 is -2. So yes, it's correct. So if I put x here, it's going to be x squared minus 3. All right. Yeah. Good. How about the last one? What rule do you want to put here? Oh, sorry. Any idea? Any idea? Multiply by 7 and 1, so 5. Yeah, but what about these two? The last one. You multiply 2 by 7 and subtract 1. It doesn't work, right? Do you know why you cannot assign rules
Because you have
here?
2 with similar in?
Yes, look at these two. What happened to this? 2 is repeated. Yes, so you cannot assign a rule. So this is not a function. Yeah, so no rule. Why? Because How can you make a rule if 2 is assigned to 13 and then suddenly 2 is assigned to 23? Does that make sense? So now let's define a function. What is a function? A function is a rule that pairs x with exactly one value of y, right? Y, you cannot assign a rule here, so that whatever you do for number 4, there is not going to be any rule. Oh, I already write no rule. So this is not a function. Yeah? It's not possible to assign any rule. Okay? Because you're being inconsistent. Does that make sense? The definition of function. So a function is a type of special relationship. It is a rule that assigns x with exactly one value of y. Yeah. So this is repeated. The n is repeated. All right. Good. So any questions so far? Are we good? Continue. All right. Determine.
But it's only one way relation, right? And that one x will always have a y, two values, right? But different x can have the same
Value of y. Yes. So good question. So Alex has a question. Does it mean that each x can have only one value of y, but can if two different x's have the same value of y, is it possible? So yes, it is possible. So for example, to give you an example, value y is equal to x squared, or f of x is equal to x squared. So y equals to x squared is a function, right? But look at what happened with two different x. So suppose if I ask you what is, or maybe it's easier to see here. Suppose x is equal to 2. What is y? 4. When x is equal to negative 2, what is y? 4 also. So two different values of x can have the same value of y. But for each of these x, there's only one value of y. So I cannot say when x is 2, y is 3 and negative 3. So if you have these, then it's paired with two different y. So something like this is not a function. So each x can be paired with one value of y. However, the value of y can be the same for two different x's. Does that make sense? If they're both 1 and 1, then we have later on we will have a one-to-one function. But we're not talking about one-to-one functions now. Yeah. So if you have this is not a function because x is paired with two different y values. Okay. Now I'm going to write a note here also. Y equals x squared is a function because each x is paired with exactly one y value. Even though the value for the two different x's might be the same y. Does that make sense? Do you see the difference? Yeah? Okay. Now let me erase this. So this is a different problem, okay? Right. So this is 1 and then this is 2. Yeah. What is it?
this is a conceptual question. Could we have a function that's not going to one relation?
A function? Yes. A function doesn't have to be doesn't have to be in mathematical context. So, for example, a person's birthday. So that's a good question. So Jorge asked, is there any way we could write a function without using any equations? Yes. A function is a relation, and a relation doesn't always come in mathematical context. So to give you an example of a function that is not, that cannot be written as equations is this one. So a person's birth month is actually an example of a function, right? Why? Because, for example, Anne, for example, myself, can I have 2 different months that I'm born on? Yeah, so I can only be born on 1 month. So that's also a function, but I cannot write it as equation. Yeah, so if it's mathematical, then every time you can write it as equations, but sometimes it's not mathematical context. Make sense? Okay. Now let's continue. Yeah, so this is a this is example of a function which is non-mathematical. Yeah, because I could only have 1 birthday. Yeah, can you give another example of a function that is non-mathematical? Come on, you can do it. I'm sorry? A pet? Oh, so a pet. Can an owner have 2 pets? Yeah, so it's not a function. Right? Okay. So, Jesus. Oh, sorry, what is your name? Josue, yes. And then Alex and Jesus. I'm trying to remember everybody's name. Okay, so whenever you say, I have to ask your name, please. Yeah. Ray and Jessica, right? So I'm trying to remember everybody's name. Yeah, and then Wendy. Jesus, what are you going to say? Oh, what? You mean the relation is person, spouse. Well, it works most of the time, right? A person, spouse. So the question is, can a person have 2 different spouses? Yes or no? No, yes? Okay. So, well, let's just say yes, because you cannot marry legally, you cannot marry more than, well, you can marry more than once, right? But on the same time, you can't have more than 1 spouse. Yeah, so yes, this is a function. Yes, another one, because legally, on the same time, you cannot have more than 1 spouse. Oh, well, what about one is here, one is the other country, then nobody knows. Well, anyway, you have to use your own context, okay? What else? What else? What about the author of a textbook? The author of textbook. No, there could be many. Textbook's author, could be many, right? This textbook is Sullivan and Sullivan, so I think the father and the son wrote this book. Okay, what else? What about the price of a textbook at a bookstore? Is it a function? In a bookstore?
Well, I mean, suppose we have to be priced.
But the price can I, if I have a store, can I sell this to you $20 and sell to the other one $50? If they have a discount, yeah, just say everything should be on par, right? I mean, if it's a discount, then it's not fair. Yeah, but in general, the price of a textbook, theoretically, it should be a function. Make sense? Yeah, anyway, it can be paired with only 1 different price, because otherwise the bookstore's cheating unless they have a discount. Yeah? All right, so let's continue. C, let's see, the C is not difficult, so C. Determine, we did this also, if the relation represents a function. So I'm going to list a few ordered pairs, well actually one ordered pair. 0, 7, 1, 5, 3, -2, 6, 2, 1, -7. And then number 2, 5, 0, 2, 7. And then number 3, I am going to write down a, actually I'm going to draw a Venn diagram. Okay, so I am going to draw a Venn diagram. Let's see. What is it? I'm just going to use number 1, 2, 7, -3, 4. So 1 is paired with -3, 2 is paired with 4, and 7 is paired with -3. So number 1, is a function or not? No, why not? The 1 is paired with 2 different values, right? So this one, so not a function. Okay, so not a function because 1 is paired with 2 different values of 1. Oh, let me add one more here for my second one. So I am adding this one. How about 3, 0? So I'm just adding this one. This is my addition. This part, 3, 0 for number 2. So is number 2, is it a function? Yes, why? Yes, each x is paired with exactly 1 y. Because each x is paired with exactly 1 y value. Okay, good. How about number 3? Is it a function? Yes. So even though the y is the same, 0 and 0 here, but 5 is paired with 1 value, 3 is paired with also 1 value. So number 3, this is the same thing as number 2, right? Is it a function? So yes, a function because each x is paired with exactly 1 y value. So far so good. It's easy, doable. And if you graph, remember you have a vertical line test. So I'm just going to mention it now. So if you graph, this is a parabola. Okay, then does this parabola represent a function? Does this graph represent a function? Yes, by vertical line test. What is a vertical line test? What does vertical line test say? So I'm going to write it here. Vertical line test. What is it?
Any vertical line on the graph can get 2 points.
Okay, so if any vertical line cross vertical line, crosses a graph at most once, then the graph represents a function. Okay? So yes, a function by vertical lines. What about the circle before that we drew? Remember the one that we drew in the beginning? This is 5 and negative 5. Does this graph represent a function? Does this graph represent a function? No. Why not? Yes, look at this. If I draw a vertical line, it crosses twice. Yeah, so no, not a function by vertical line. So you can see why this x right here, I don't know what x this is, it's paired with two different y values. So this is the first y value, and this is the second y value, right? So you can see this x right here, maybe 3, maybe 4, is paired with two different y values, which is this y value, this y value, and this y value. Yeah. Okay, let's continue now. All right. Ready? So this is review, right? Okay. D. Did everybody finish? Yeah? Okay. So D. By the way, I write these, is it big enough from the back? The back people, you guys can see? Okay, so it's clear, right? Okay. All right, now what we want to do is finding values. Usually I try to write bigger, but then I forgot. So at the end it gets smaller and smaller. Finding values of a function. Okay. So let's say f of x is equal to 5x squared minus 2x. Okay. So I'd like you to find a few things. So number one, what about f of negative 2? Diana, you have a question? No? Okay. So f of negative 2. Number 2, f of negative x. Number 3, f of x plus 3. So let's do this first. What am I going to do here? Yes. So 5 times negative 2 squared minus 2 times negative 2. So what is this equal to? 5 times 4, 20 plus 4, 24. So you could write 20 plus 4, or you could write 24 directly. Okay? Or you can write 5 times 4 plus 4, or something like that, whatever you want. F of negative x, what's this? What do I do? Substitute as usual. So 5 times negative x squared minus 2 times negative x. So this is 5x squared plus 2x. Yeah. So you see anything that has even exponent doesn't change if the input, the sign of the input is switched, is the opposite. Yeah. So it's still 5x squared. But anything that has odd exponent of x, the sign is switched. Yeah. What about f of x plus 3? 5 times x plus 3 squared minus 2 times x plus 3. So this is 5 times, what is x plus 3 squared? X squared plus 6x plus 9, yes, minus 2x minus 6. So 5x squared plus 30x plus 45 minus 2x minus 6. So what is this equal to? 5x squared plus 28x plus 39. Okay. Now, I'd like you to try this one. F of x plus h minus f of x over h. And we are going to say h cannot equal to 0. Well, because h is the denominator. This is called difference quotient. When you start talking about limits in calculus, this is one way of expressing limits. Yeah. Okay. So it's the as expressing the derivative. So derivative of limit as h goes to 0 of these. Anyway, you'll see this again in calculus when I think the beginning of chapter 3 in calculus. Yeah. So this is called difference quotient, and it's related to the definition of derivative using limits. So what am I going to do? What is this equal to? What am I going to write here? 5 times what? X plus h squared. So basically whatever we have here, the x is replaced by whatever I have. So f of x plus h, what's that? 5 times x plus h squared minus 2 times x plus h. So this portion is f of x plus h, isn't it? Okay, good. Minus, so this is the first portion. This is f of x plus h. Minus f of x. What is f of x? Yes, 5x squared minus 2x. Divided by, should be a little straighter. Divided by h. Yeah. So let's see what is this? What is x plus h squared? So 5 times x squared plus 2hx plus h squared minus 2x minus 2h. Oh, let me just take out these parentheses on the second one, right? Minus 5x squared, and then what is this? What am I supposed to write here? Plus 2x. Everything divided by h. All right. So what do I have? 5x squared plus and hx plus 5h squared. Is that right? Minus 2x minus 2h minus 5x squared plus 2x over h. So which one cancel? 5x squared? The 2x's? Okay, so you have 10hx plus 5h squared minus 2h divided by h. So then what do I have? And x plus 5h minus 2. Yeah? Okay. Now, maybe some of you learned calculus. What is the derivative of 5x squared minus 2x? 10x minus 2. Well, I mean, just ignore me if you never learn. But the derivative of 5x squared minus 2x is you bring down the exponent, so 2 times 5, and x minus 2. So here, if you set h equal to 0, then you will have also 10x minus 2. Yeah. So later on, when you're doing calculus, the very beginning part, when you talk about derivative, you're going to have to do this. And then they will add these limit as h goes to 0. So you have to carry the limit. What does it mean? We will substitute 0 for h at the end. So when I substitute 0 for h, what do I have? An x minus 2. So the derivative of this is an x minus 2. But that's later. Okay? So don't worry about it now. We'll just stop here. This is called difference quotient, and we will use it in calculus. Yeah? All right. Now, number 5. What about if I have 5 f of x? What is 5 f of x? It's easy. What do you do? Yeah, so it is 5 times whatever we have. 5x squared minus 2x, right? So this is 25x squared minus 10x. Good. And the last one, what is f of 2x? Oh, this is easy too. What do you do with the 2x? Yeah, same thing. So you're right. 5 times 2x squared minus 2 times 2x. So this is 5 times 4x squared. So remember 2x squared, you have to square the 2 also. Minus 4x. So what do I have here? Well, yeah, minus. Okay, so far, which part is not reviewed? Maybe a little bit of these, right? A little bit. How about the other one? So far, they're reviewed, right? Maybe only the difference quotient. Yeah. Okay, good. So we're going to move on to find the domain. So E. If you're done. You done? Okay. So E. All right. Finding domain. So remember, domain is, what is the definition of domain? The set of all possible inputs or all possible x values. Okay, and range is the set of all possible outputs, which is the y value. All right. Okay, how do you find domains of function defined by equation? So finding, I should change my title, finding domain of a function. So I'm adding this, okay, sorry, on the title. Defined by equation. By an equation. Oh, sorry. So what we need to do, like, first start with all real numbers. As the domain. Number 2, if equation has a denominator exclude all values which are the zeros of the denominator. Why do we have to exclude values that are zeros of the denominator?
Because the
Yes,
denominator
the
cannot
function
be
is undefined. If the denominator is 0, the function is undefined. Yeah, so first of all, you will think, oh, the domain is all real numbers. But then if it has denominators, then exclude those values. Now, the other thing is radical. Yes. So if the equation has a radical with even index, so odd doesn't matter, but even index, meaning 2 square root or 4th root or 6th root, then the radicand must be greater than or equal to 0, because otherwise it's undefined, right? So if I talk about square root of -4, what is square root of -4? 2i? Yeah, but I is not a real number, so it's not defined in real number. It is an imaginary number. Am I right? Okay. So that's why if we have a square root, then we need to make sure that the radicand is the expression under the radical sign, must be greater than or equal to 0. Yeah, so square root of -4, this is not defined in real numbers. All right, so let's talk about it. So number 1, find the domain. So for example, find the domain. Number 1. Maybe I should close the door because it's a little noisy. Okay, so what about this? This is, oops. Oh, I was going to write f of x is equal to x squared plus 2x. What's the domain? All real numbers. So domain is all real numbers. So I could write it like this, okay? Or I could write it, this is called set builder, x such that x is an element of real number. So this is called set builder notation. Or how do I write in interval notation of all real numbers? Negative infinity to positive infinity. Yeah, so this is called a set builder. This is called interval notation. This is set builder notation, interval notation. All right. Now, what about if I have f of x is 5x over x squared minus 4x minus 5? So what's the domain? So let's factor the denominator. So can we factor the denominator? What is this? X minus 5, okay. X plus 1, yes. That's right. Then what is the domain? Which one do we exclude? What values do we exclude? 5 and -1. So actually it might be easier for you to draw the real number line, and then we exclude 5. So we have an open circle at 5, meaning we exclude 5 and -1. Yeah. So the domain is all real number except -1 and 5. How do you write it? This is your set builder. X such that x is not equal to -1, x is not equal to 5, and then x is an element of real number. So this something like E here, this is an element of. And sometimes we don't write this part right here because it's understood we're talking about real numbers. So sometimes it's just going to be x such that x is not equal to -1, x is not equal to 5. And then we do not include x is an element of real number. Yeah, because it is understood that it is real number. Now, how do I write this in my interval notation? Okay, so -infinity to -1. So how many intervals do I have? How many? 3. So this is the first one, this is the second one, this is the third one. Okay, so you represented the first interval. What about the second one? Union. So this U is union, 1 to 5. And the third one? Union. Oh, I don't have space. I have to write it down here, okay? What's the third one? Union, 5 to infinity. All right. Yes? Oh, you are right. I forgot this. This is supposed to be negative. Thank you. Yes. What is your name? Yeah. Tom Ping? Okay. Okay. Thank you. Yeah. So if you talk, then I'm going to ask your name. Yeah, because I want to know everybody's name. I try to remember everybody's name. Good. Yeah. Thank you. Now, the third one. Okay. Let's see here. Number 3. I wouldn't have space over there. So what about f of x is equal to square root of 5x minus 12 divided by x plus 5. So I have a radical with an even index, and I also have to exclude values from denominator. So what am I going to do first here? So when I'm trying to find the domain, what do you have to remember here? Exclude what? Exclude 0? Why do you exclude 0? Exclude -5. That's what you have to remember. Okay, good. What else? 5x minus 12. So 2 things. Maybe I should write these, because otherwise you think it is a negative sign. Must be greater than or equal to 0. Okay. So what is it? 5x must be greater than or equal to 12. So x must be greater than or equal to 12 over 5. Right? Now, if I draw these on the number line, how would I? Oh, how do I write it in my set builder? X such that x is not is greater than or equal to 12 over 5, and x cannot equal to -5. Okay, good. Oh, but isn't it included already? Because -5 is on the other side. Do I have to include this part? So what is the value of 12 over 5? What is 12 over 5? 12 over 5 is what? Yeah, so 2.4. Is it? Yes, 2.4. So this is 2.4 or 12 over 5 to the right. Okay, and then this is -5 right here. So and then it says that I have to exclude this, but this is my domain. So do I have to include this part? No. Yeah. So because this is my domain right here. So it is just x such that x is greater than 12 over 5. So this one is not part of my domain. Okay. My domain is just this part. And how do I write it in interval notation? So this is set builder. How about interval? Okay, what do I use? Parentheses or bracket? Yes, bracket, parentheses, bracket, comma, infinity. Yes. So these are the domains. Yeah. So this is your set builder. Oh, sorry, this part. And let me erase this. And this is your interval notation. Yes, so far so good? Okay. Now, I have 5 minutes, right? Okay. What I want to do, is it F, G, or what? The next one. Is it F? F, yes. Sum, difference, product, and quotient. Sum, difference, product, and quotient. So the sum is f plus g of x is equal to f of x plus g of x. I mean, you guys know this. This is difference. F minus g of x is f of x minus g of x. Product is what operation? Yes. Oops. F times g of x. This is equal to f of x times g of x. Quotient? What is quotient? Division? Yes. F of x over g of x. Well, what happens here when you divide by g of x? We need to write down something. G of x cannot equal to 0. Yes? Okay, now let's talk about the domain. The domain of f plus g, f minus g, f times g is, I'm going to write this, domain of f intersection domain of g. So the intersection of the domain of f and g. So remember, this is what? What do we call this? Union. And what do we call this? Intersection. Do you know the difference between union and intersection? What is the difference between union and intersection? So suppose this is actually a review. Let me see how much time I have. So suppose A is 1, 2, 3, 4, 5. Okay. B is 1, 3. So I'm doing I am writing about the domain, the intersection. What is the difference between intersection and union? How am I going to draw the Venn diagram here? Do they intersect at all? Which one? 1, 3, and 5? Okay, so here A and B has intersection, and the intersection is 1, 3, and 5. Right? What am I supposed to write down in A here? 2 and 4. This is called the Venn diagram, and I have to use this dot here for each member. So dot 2, dot 4. Yeah. And what about in B? 7 and 9. The intersection is 1, 3, and 5. So A intersection B is 1, 3, and 5. So the elements that are common in A and B. How about the union? What is the union? Everything. So what is it? 1, 2, 3, 4, 5, 7, 9. So we're not listing any of the elements twice. We're only listing them once. Okay? All right. Now, what is the domain of F over G? What do you think? Excluding the values that make G of X equal 0. Yes. So, good. So let's write down the domain of F over G on the next page. Yeah. Are you guys ready? So the domain of F over G is domain of F intersected by domain of G. So it's the same answer as the other one, but with the addition. What is the addition? Excluding values. So you have to exclude more values for which G of X is equal to 0. Okay? Okay. Now, can we do problems? I think I have only 3 more minutes. Maybe I'll go over time a little bit. Okay. Sorry. I'll let you guys go a little bit earlier tomorrow. Okay. All right. So, for example, given f of x is equal to 1 over x plus 3. All right. And g of x is equal to x over x minus 2. What I want you to do is so find f plus g of x and its domain. Okay, so let's do it really quick. So f plus g of x, so this is your answer. What is it equal to? Well, 1 over x plus 3 plus x over x minus 2. By the way, tell me what is the domain of f. So let's see here. So tell me what is the domain of f. X such that x cannot equal to what? Negative 3. What is domain of g? X such that x cannot equal to 2. You're right. Yes? So you're excluding negative 3 from f and 2 from g. Good. So what do you do now? Algebra. How do you add these two? Common denominator? What is the common denominator? Okay. X plus 3 times x minus 2. X plus 3 times x minus 2. Then yes, you're going to multiply. So multiply by what, the first one? X. Alright. So on top I will have x minus 2, correct? How about the second term? What do I multiply these with? X plus 3. So on top, what will I have? Okay, good. So when I add these, what do I have? On top, x squared plus 4x minus 2. All right, good. Yeah. So you're done with f plus g of x. Now its domain. So what is the domain of f plus g of x? So what is the intersection between the domain of f and the domain of g? Which one is the intersection? Which one? So what does f say? Which one do we exclude from f? -3. Which one do we exclude from g? 2. So what is the intersection? It's everything excluding the -3 and 2. Yes. So this is x such that x is not equal to -3, x is not equal to 2. And optional, you can write x is an element of real number, but you don't have to. So you could write these, or you could write x such that x cannot equal to -3, x cannot equal to 2, x is an element of real number. These two are equivalent. Yeah? All right. Good. Hold on, I'm not done. One more. Yeah. B. What about f over g and its domain? So I promise you tomorrow I'll let you guys go earlier a little bit. I need to finish because this is it's going to take a few minutes only. Yeah, I mean we want to finish. We don't want to leave it for tomorrow. Because you guys need to know. What is f over g of x? So answer, f over g of x is f of x divided by g of x. So it is 1 over x plus 3 divided by x over x minus 2. So what is this equal to? Can I write these as multiplication? Times. So division, this is division. So I could write it like this, x over x minus 2. So then division is the same as multiplication with the reciprocal. So this is x minus 2 over x. Yes. So what's my times? Oh, actually we leave it in factor form. Yeah. So this is f over g of x. Good. Now, 2 more minutes. What is the domain of f over g of x? What's the domain? So which values are we excluding? Oh, we are excluding -3. We are excluding 2. One more thing we have to exclude when g is equal to 0. When is g equals to 0? Yes, when x is equal to 0. So we exclude one more. So exclude values when g is 0. So x is equal to 0. So we exclude one more. So what is the domain? X such that x cannot be 0, x cannot be -3, x cannot be 2. All right, so that's the domain. Okay? All right. So far, so good. So we use the answer here, and then you have to do one more when g of x is 0. Yeah? Okay, guys, see you tomorrow. I'm going to call the attendance tomorrow. Don't worry about it today, okay? But we're done with 1.1. Yeah? Okay, so I'm going to close the recording now. Yeah, give me a second after I... Is everybody done with this? Okay, I'm going to close it. You're not done? Okay. Let me stop the recording and then I will pull the PowerPoint back on, okay? So Diana and Oscar, we will see you tomorrow.
Bye. Thank you.
Okay. Yes. Oh. All right. So let me stop the recording.